is the most widely used building material in the world, and it is even more so with a view to the rapid urban development, especially in emerging countries. The main component of concrete is cement. That I think you know better than I do. And cement production is expected to increase from around 4 billion tons per year to more than 5 billion tons by 2050. Currently, cement production is responsible for about 8% of global CO2 emissions, a fact which has been widely circulated with regard to this conference here, COP27. According to the International Energy Agency report on cement, we are not yet on track to reach net period. To achieve a net zero future, improvements are needed at different life cycle stages. Cement short LC3 from the laboratory to large-scale production. LC3 was developed by the Swiss Federal Institute of Technology in Lausanne, EPFL, here represented by Professor Scrivener, in collaboration with the Indian Institute of Technology in Delhi and Madras and Universidad de las Villas in Cuba. A real joint effort. Joint efforts and the exchange of experience within international scientists have led to this exciting result. And my sincere thanks go obviously to all the scientists involved. LC3 cement. LC3 is a cement that is not only less carbon intensive, it is also resource efficient, energy efficient, cost effective and high performing. Moreover, it is a ready-to-use technology, which is why cement companies are increasingly adopting LC3 worldwide. I am pleased that the Global Cement and Concrete Association and major companies are also fully behind LC3, which is essential for further dissemination. LC3 is an essential contribution to decarbonizing the cement sector and achieving the goals of the Paris Agreement. I am very pleased that LC3 is accepted under cement standards applicable in Europe, the United States, India, Cuba, and much of South America. Representatives of governments are challenged to create a more sustainable building and construction sector by pursuing ambitious public procurement policies, setting industry standards and emission norms, and developing roadmaps for decarbonization. Cement manufacturers, on their hand, are faced with the challenge of reducing CO2 emissions. LC3, I'm sure, will play a decisive role in this, so let's ramp up the production together. Thank you very much for your attention, and I'm wishing you Hello? It's working now? Okay. So if we can go to the slides, please. Okay. Now, so this clicker is not working, sorry.
the materials put together, and this is why they make up more than 8% of CO2 emissions. From an intrinsic point of view, as intrinsic energy and CO2 compared to other materials. The other important is where the demand for cement is going to be in the coming years, that this is going to be overwhelmingly in the global south. This means that we must have solutions that can be used by everybody everywhere, and not solutions that are very sophisticated that become a micro niche. The other issue we are facing with cement is the origin of the CO2 emissions, which are coming from more than half of the emissions, about 60%, are coming from this simple chemical equation, which is the breakdown of limestone, 80% of the raw material, into calcium oxide and CO2. Now, this material we call Portland cement. We cannot really come with alternatives because the chemistry and geology of the earth means it's the only material we can produce on the scale needed. But we can replace a large fraction of this Portland cement by other materials. And this has been done very successfully over a few decades now. But the issue is that the materials we are commonly using as replacements, which are what are called slag and fly ash, you see in the middle here, the amounts available are really quite limited compared to the demand for Portland cement. And these materials, the amounts will decrease in the future because they're coming from very CO2 intensive industries. So this is where we started from, and we looked at what materials we could use as alternatives. Limestone is widely available, but the problem is it has low reactivity. And then we came to the clays. Clays can produce very reactive materials when they're what's called calcined. That means heated in the range about 800 degrees. So in a nutshell, the blended cements will be the most viable option for the future. And the only material which can extend this use of blended cement are calcined clays. And our discovery at EPFL was that we could have a synergistic reaction between limestone and calcined clay, which can allow us to go to very high levels of substitution. So we discovered this about 2008, and since 2013 we have been supported by the Swiss government through their Agency for Development and Cooperation to bring this technology to the industry. And the QR code here will take you to a brochure which describes the project in more detail. So in a nutshell, this is why we can reduce CO2. So on the left there, we have conventional clinker, which is producing a lot of CO2. In LC3, we can replace at least 50% of that clinker by other materials. So we replace about 30% with calcined clay, which has a little bit of energy for calcination, but much, much lower than clinker. And then the other part by limestone and gypsum, which have no CO2. And what's really interesting is the fact that with this material, we can obtain the same or higher strength than the reference Portland cement in as little as 7 days. So in a nutshell, we have 50% less clinker, 10%, 40% less CO2, and some properties like resistance to chloride ingress and alkali silica are immensely improved. So our first issue was to find the right kind of clay. We don't need very high purity materials. We can use materials with just around 40% kaolin, and these materials are very widely distributed worldwide. Everywhere you can see this kind of yellow color, you will have suitable materials for making this calcined clay. And you can see this is particularly good in the developing countries where the demand will be strongest in the coming decades, but also in Europe we have some quite good areas. This is a technology we have really brought to the field. This is our first demonstration house we built in India, where we could demonstrate saving in just this one house of 14 tons of CO2. And now we have full-scale plants. This is one in Ivory Coast, which are producing calcined clay. From a financial point of view, it's almost also very good news, because you can save costs. And while we're all trying to promote CO2 savings, I think for industry, the real winner is if you can say that you can produce this more cheaply. This will be the real driver for the uptake. Of course, there is some barrier in terms of installing new equipment, but this also is relatively low in this field. So the potential for this technology is really enormous. This graph here shows the current average levels of substitution worldwide, and it has stagnated in the past decade to around 20% because of shortages of slag and fly ash. If we remove that obstacle, which we can easily do by calcined clay, it's generally agreed we could go to substitution levels of at least 40%. This would represent a saving of over 400 million tons of CO2 per year. And I think on a horizon of 2050, it would be imaginable to go to 55% substitution, which would be double that. And this is like 1 to 2% of the entire CO2 emissions of the world today. So a very substantial saving from one single technology. So in a nutshell, these are the advantages. We save carbon, we can use otherwise waste resources, we have performance which is very similar to the reference, we can totally scale this up. We can save up to 25% of production, and it can be used immediately just as the conventional OPC with no special training. So from this point of view, it's a feasible solution for both climate production and development. It's not going to be enough. If we really want to decarbonize cement, we have to be able to move right through the value chain, not only reduce clinker in cement, as I've been talking about with LC3, but cement in concrete, concrete in buildings. But I think if we really develop these aspects, there can be savings even up to 80% of the production today. So with that, I'd like to thank you, and just to summarize, that we can really make a lot of reductions on the what is coming from cement and concrete by working at the different levels, by using LC3 at the cement level, but also working on reduction at concrete and building levels. And these are technologies available today which can be introduced at large scale and fast. So this is what we have to do. And thank you for your attention. So now I'd like to move on and ask Thomas Gio, who is the CEO of the Global Cement and Concrete Association, to present on here.
So, thank you very much, Karen. Thank you very much. Delighted to be here. Thank you very much to the attendees. Hello to the people on stage. So maybe a few comments from my side, highlighting actually the benefit on the use of calcined clay at global level. So maybe first a few words on GCCA. I'm pressing the right button, right. So GCCA is the Global Cement and Concrete Association. We are a CEO-led organization, and that's important because the commitment that is made in the association actually bear on carried by the leadership of the company that we represent. We are about 80% of the cement sector outside China, and we also have in our membership some key Chinese manufacturers, such as CNBM in particular, which in itself produce 500 million tons of cement every year. So we have 41 industrials, but we also have more than 30 national cement associations. We hope to have Switzerland maybe one day as an affiliate. I will work on that. And we are actually having this discussion, and we are helping the industry to transition through the net zero. And that's basically the main goal of the GCCA is to help transition on the net zero, on getting the objective of 2050, which is the net zero. Why concrete is essential? I mean, Karen said it. It's a question of geology of the planet Earth. I like actually very much that explanation. Cement and concrete is the backbone of the modern society we live in. On whatever you think development, whenever you think long term on modern society, there is a backbone, and this is cement on concrete. Hospitals, infrastructures, house. And the second desire of mankind is, after eating, is probably to get a floor on the foot and a roof on its head. So it's fundamental and important. And we are present all over the planet. That's what is special. It's basically the popularity of that material that makes it available all over the planet. So we do have a roadmap. We worked on, we published in 2021 for the last COP, actually, a net zero roadmap, which consists of first multiplying what we have been doing, and then working this decade, 2020-2030, on technology, on innovation, and on progressing the things that we have been doing so far well, including circularity, including different elements. I'm going to come back. But what is important here is actually the acceleration that we want to do, and in particular, on the different levels for decarbonization. So you have here the various levels. I will not go in details. The first one is about construction. How do we build? Thinking the construction as a whole, and making sure that we are efficient also on putting CO2 consumptions at the heart of the way we design houses, at the heart of the way we design buildings on infrastructure. We have also, that's the second level in green, 11% progress to do in the way we use the powder. So basically that's how much cement in concrete, if you want, and that's an important part. And then you have actually this pink-orange lever here, which is the usage of cement bed. And that's where the CO2 kicks in, and that's where the LC3 kicks in. So this is about how much clinker, which is the heavy component, the CO2 component of that we put into the cement, how much we put into cement. On Karen expressed it very well. It's a question of how much can we save. So here we see a bit of I mean, Karen used to say, always tell me that 9% doesn't look a lot on the global level. Well, that's because of China being already quite advanced in low carbon concrete, or actually low clinker factor concrete, and therefore it weighs a little bit on the rest of the world. If we take, let's say, the world outside China, that would be closer to 20 points of a lever. So it's a really important lever, this aspect, for the world outside China. I would say also in China. China will do progress and will use it, but it's particularly important for the world outside China. And finally, you have this big purple part. Magali made us a pleasure to actually represent this lever, probably. the carbon concrete, the carbon capture used on store. And that's also the big solutions. We will have many talks about it during the COP. There are many events about carbon capture, and we'll come back on that. Now, if I drill a little bit on this 9%, why it's really important. It's fundamental because today, Karen said it also, there is a disappearance of slag, of fly ash. These are byproducts from industries that will go into a decarbonation as well. So they will fade out and they will reduce the amount of material available. There will be less and less electricity produced with coal, that's what we hope. And there will be less and less crude steel produced in the world. So the availability of this material will reduce. And in fact, calcined clay is really the alternative and one of the options that make us believe that this roadmap is sensible and makes sense, and that we have actually an options to these materials. They will be over, but they are, in general, in lower availability. And the beauty of calcined clay is really the availability at the global level, and in particular in the global south, where the growth of the cement is expected to happen. So you see the famous clinker factor. We are today around 63%. We plan to bring it down to 58 by 2030 and then to 52 by 2050. This is related to the number that Karen gave earlier, the famous 40% replacement in cement on 55 in cement. So we are more or less consistent, although not having done it together fully. So what is Alcalce and how is the popularity of calcined clay developing? Well, actually, I was saying, so I mean, it's something that is actually easier to make than clinker in some ways. It's actually less energy consuming. And you need to find the clay deposit. And these clay deposits, as we said, are largely available. Fundamentally, we have tested and we have proven that this material is acceptable in most of the places of the world, in all of the places of the world. We are working on standards with the industry. I mean, this is part of our policy ask to adapt the standard in the country to make place for this material, for this calcined clay cement. The latest one was in Europe, where the cement standard was adapted, thanks to the cement industry that pushed to make it happen. A short map of the latest development, and I think we have here Magali that will tell us more about the whole CIM1. But there are many, all over the world, many projects on calcined clay that are aiming at developing on having sizable quantities on sizable investment on calcined clay and on the development. So really for us, as an industry, this technology is a fundamental technology. It's a very important pillar of the decarbonization strategies. All our members are really committed to make its development. I mean, that's just one example. We have to continue and we'll keep tracking the project and reports on these projects together with Karen in all transparency. And Karen, on behalf of the industry, I would really much like to thank you for all the effort on the development that you have done during many years to develop these technologies and to make it available for the industry. So really, I mean, it's important to say it. Thank you very much. I give the word to Magali.
The lady in purple doing CCUS. So, no, I don't have slides. Good morning, everybody. I'm really, really happy to be here. And I'm extremely excited to be sharing a panel with such distinguished panelists. And as Thomas just said, really, Karen for me is a bit of a goddess because of how much she has made the industry progress. And of course, thank you to the Switzerland government for putting that so strongly in the agenda. So at Holcim, you know, my job is to find a way to decarbonize 180 million tons of CO2. So what we did is we did what most companies have done. We did a net zero pledge. We announced we would go to net zero by 2050. We have our target validated by SBTi, Science-Based Target Initiative, without intermediate target for 2030, even for 2025, to show that we want to work now. And regularly, as I am also in charge of innovation, I looked at all the innovations around. It was mentioned already several times, concrete is the most used material in the world. And I see those wonderful innovations, but my job is to decarbonize 180 million tons of cement. And I don't have time for small scale. I don't have time for little projects that are great, and I encourage everyone else to do it. But what we need to do, if we want to really maintain this 1.5 degree, is scale it up and scale it up fast. And that's exactly what calcined clay can do for cement. That's the only truly scalable alternative to cement. So as a company, it's fantastic, right? Because, you know, wow. So I don't need to wait for 2045 to do my commitment for 2050. I can work on it right now. And that's what we have been doing. So we launched a huge research of kaolin clay. So you know, it's great to pass after Karen and after Thomas, because I don't need to explain all those words. You already saw it, so you are super expert in clay now, so you know what is a kaolin clay. Because as you saw on the slide from Karen, if you are too far from the plant, it can add logistic cost and everything that could be quite having a negative impact on your overall production, which as a company, It's not that we don't want to do it. We really want to do it to save CO2, but if in the same time we can do it with a better benefit, then it's a full win-win situation. And that's, you are sure, we will do it, and we will be very enthusiastic about doing it. So we looked at all the kaolin clay, and so far, and the progress is still ongoing, even though Thomas showed the map where there was, what, less than 10 projects? Well, we have identified 11, just Holcim. So they are not public for the majority of them for obvious reason, because we want to make sure we secure the source before we start talking about it. But the very good news about it is half of them are in the global south. And you know, there is always this question that we get as an international company. So you are having all these projects in Europe because CO2 has a price in Europe. What do you do in the global south? And well, now I have an answer. I'm not saying I didn't have an answer before, I did, but I have an additional answer, which is calcined clay. And the one that is not on the map, but is so relevant to this COP, is our biggest project is actually in Egypt here. So when I see the numbers, it will be one of the biggest production of calcined clay cement in the coming years. So that's super important, because our plant in Sokna, not so far, I mean closer to Casablanca to here, is one of our biggest production plant in the world. So being able to shift in a very near future from traditional cement to calcined clay cement, at least part of the production, is important. Now, I was mentioning innovation. That is not the only thing we do. We have today 4 patents filed, because we are looking at the calcination itself, how to lower the CO2 of the calcination itself. We know how to do it for OPC cement. It's not as it's not that not as easy, but maybe not something we were looking at in the past for calcined clay. So we can also go to zero as a calcination process. So we have 4 patents filed. We have 1 ongoing. And again, it's absolutely at the heart of the strategy for all the reasons that I would have shared with you if it was not already shared by my predecessor, which is basically, it's absolutely critical for the industry to lower our clinker factor. And the traditional ways of doing it, of using slag and fly ash, we absolutely know that is going to disappear in the coming years. And the future will be for the people who are prepared for that. And I'm really happy to say that Holcim is prepared for that. Thank you very much.
Thank you so much, Magali, and this is great news to hear how engaged you are in this project, in this technology. So now I'm very happy to hand the word to Rajiv Garg from UNCTCN, who will present about the potential in Africa.
Thank you. Okay, you know, I would not like to go in much details about the use and the benefits of calcined clay. It has been already mentioned by my previous speakers. Kind of just give you a snapshot or an overview. Again, these are from secondary sources which were found when we did a bit of a research, but it is more on the profile of the cement sector and how it is going to grow in Africa. About CTCN, an overview of the CTCN on how CTCN is supporting countries on technology transfer issues. And what is our thinking? What is our thinking in terms of how we can take this specific technology, LC3 technology, further in the developing countries and support them in implementation of this project or this. Largely, our research shows that around in Africa in 2020, the total cement production is in the range of 200 to 215 million tons. it is expected to grow. It is expected to grow at a rate of something like 2.6% on a combined on a cumulative annual basis. The North African countries are the biggest producer as of now, but also the thing what has to be realized is that most of these cement plants, the capacity utilization is still 50%, or still in the range of 55 to 60%. It means that they have the capacity with the same plant to produce. Is growing, urbanization is happening, and there is large infrastructure development. So definitely the utilization of cement, or the demand for the cement, is going to increase day by day. A bit about CTCN. We are a body under the technology mechanism of the UNFCCC. We have national designated entities or focal points which are appointed by the respective government in each of the developing country, and we work through them and support them on their demand. Anything related to technology issues on technology transfer through the technical assistance, which are small in value, but they are demand driven. So if the countries want a support on technology X, we provide support on technology X. If the countries say that they want to have a support on technology Y, we say, okay, why not X, why Y, and good countries in accessing those finance for technology transfer issues. We ourselves do not have a large resource, but we support countries in whatever resource we have through small technical assistance project. But as everyone is talking about scaling up, so there is a larger effort required even on our side to see how this can be scaled up. The Climate Technology Center and Network has developed a new program of work which has been endorsed by the parties, and this program of work focuses on two key enablers: national systems of innovation and digitalization. And we have the 5 areas where systems transformations are required in the countries. And definitely business and industry is one of it, and buildings and infrastructure is one of it. So if we look at the cement sector, these would be the primary 2 drivers, both building and infrastructure and business and industry, where this kind of an action can be initiated. In the cement sector, some of the examples which we have done, like we have worked in Republic of Congo, Brazzaville, and this consisted of kind of general audit technologies of the cement plant, developing concepts on how audit can be done, the reporting guidelines, coming up with minimum specific energy consumption, how it can be improved. So it was more on the energy efficiency side, on the GHG emission reporting side. Although after this, and the Republic of Congo has put up an additional request which is under review on how we can take the next step. We have also worked in South Africa, and there were some small talks about carbon capture and utilization. And in this particular technical assistance request, which we did in the early formative years of the CTCN, we explored the possibility or looked at the feasibility of waste heat recovery system, and we also looked at how the carbon dioxide can be captured and can be utilized in the cementitious material, so that it becomes a kind of a closed loop and a closed cycle. So there are some technologies which are related to that, and we explored to what extent it can be applied and what is their feasibility. Again, in Mozambique, if you look at at the roadmap which was produced, which is produced by the Global Cement Association, Concrete and Cement Association, there are 3 or 4 elements to it, and fuel substitution is one of it. And in fuel substitution, in Mozambique, there is a cement plant. I think it was from Holcim, if I remember correctly, in Mozambique, where we tried to explore that if we use the fuel which is derived from the refuse, or the refuse derived fuel, will that be acceptable to the industry how it is going to be used, and we did a kind and what is going to be the cost economics of it, and we did this kind of a feasibility assessment, and the results were quite very astonishing, because if now refuse derived fuel, if we found out that if the waste is coming from a specific area in a locality, and you subject it to conversion to a fuel conversion, then it was quite very feasible, the economics worked out. But if it is a mixed kind of a waste and it comes from the open dumps or through the through other localities, probably the economics was not turning out to be in favor of using the refuse derived fuel. So definitely the technology is feasible, but it also depends on where you are sourcing your refuse from, or where you are sourcing your waste from. So these were kind of 3 examples which shows the different aspects which can be initiated, which can be done in different countries. But if you look at the total roadmap, it would be a culmination of all these 3, that is carbon capture and storage, fuel substitution, energy efficiency, and also the use of LC3 technology, which is the most promising of the technology, because it has been said that it would lead to 40% reduction in the GHG emission, and you can use the same plant. There is only a subsidiary plant which comes up, which for calcined clay, or you can outsource it, and you know, and that would be also a boon for cement producers who are just doing grinding, because that is where the mixing between the clinker and the calcined clay would happen. So we discussed this internally. We discussed it with some of the countries, and this is a kind of an approach we would like to encourage the countries to take up with and come to the CTCN. Means definitely there is need for an analysis of the national cement industry, analysis of the decarbonization levers, development of a roadmap, and updating of standards. One thing which came out in our discussion with the countries is, you know, if we want to apply this LC3 technology, the first step the country needs to do is change their standards. They have to allow, because countries have somewhat fixed up the percentage of clinker which has to be used in a cement. Rather than being based on the strength of the cement, they have put in a percentage of clinker which has to be used. Now, until and unless you change that rule, or you change that standards, and becomes more on a strength basis of concrete, or strength basis of cement, you know, whatever you do, the industries would not be able to adopt the technology, and this is one of the biggest barriers. And we have to, if you remove this barrier, with the cost economics all working out, the private sector by itself is going to lap up this technology. So the first bottleneck is definitely updating of and revising of the standards, and this is what we would like to focus in the future, or we would like the countries to request us in the future to focus on this particular aspect, because this is the real policy barrier which is kind of, you know, preventing the rapid uptake of the LC3 technology. And this is what we realized after we discussed with various countries. Definitely the roadmap is required, but you know, when you start developing into roadmap, you are not just concentrating on the LC3 technology. Then you start concentrating on various other aspects. You start concentrating on energy efficiency, you start concentrating on fuel substitution, you start concentrating on whether CCU is possible or not, and it becomes a kind of a longer term, a larger term perspective of what the countries can do. But for what immediately the country can do, if you can really target this aspect of removing the barrier of the current cement standard, definitely it has a large potential of a rapid uptake of a particular technology. And this is what, as CTCN, we would like to focus on. So if we get a request from the countries, we are trying to direct them to, okay, let's see what your standards are, how we can remove it, what do you need to remove it. Definitely there also you need some technical studies, you need to convince them that this technology is going to work out the cost economics with them, etc., etc. So you know, this is what the CTCN is focusing, would like to focus on. This was my last slide. Thank you very much. Happy to take any questions.
So thank you very much. So just to wrap up this session, we come back to the home country, and Andy Kokala will present just about what is going on in Egypt.
Good morning. So I will tell you about the roadmap. So the roadmap that was explained on global level, we developed the roadmap in Egypt. No. So just quickly, some information on Egypt, not on the country, but on the cement. Population Egypt will grow by 56% in 2050. It's already one of the biggest cement producer in Africa. Out of those 4 countries, they represent 50% of the production in Africa already. But, there's a but. Today, in the country, they have the highest CO2 content in their cement, which means they have a clinker factor of 89%. And that was one of the biggest issues. We did the same analysis. Yes, we did the same analysis with all the levers. And as you can see, one of the biggest and the quickest implementable lever is cementitious material. You have to understand that in Egypt, you don't have fly ash. There is no color power plant at all in Egypt. They don't have access. You don't have access to GGBFS, so this slag, or a very small quantity but very bad. They don't have much of steel production here. What do they have left? Limestone. They have some pozzolana, but they have excellent kaolinite clay deposits, which means that the possibility to reduce the clinker factor is huge. And this is one of the biggest levers that Egypt has to work on. What does that mean? The industry already did a lot of sampling, a lot of testing. The quality is there. They tested on concrete. The strength is there. Oops, sorry. But what is needed is, like Rajiv said, we need to change the cement standards. But not only. We need to change the concrete code. And we need to change the building codes, which means that we need to discuss down the supply chain with the industry, the concrete manufacturers, the designers, the structural engineers, and the famous consultants. The consultants are, in this country, very, very powerful. They can write down any building saying, I want a SEM1 with so much kilo per cubic meter. We have to change the whole setup of their thinking, and they need to understand what is new cement. We need to have a knowledge sharing with those people, because somehow the cement standard is easy to change. Not that easy, but it's easy. The building codes, that's where we have to fight much more. And because there we have in front of us different stakeholders that the industry never talk to, which are the consultants. I think we're trying to have here in Egypt multi-stakeholders dialogue with the academics inside in order to bring the knowledge to the consultants and the structural designers. So that was it for me. Thank you for him.
Okay, so thank you to all our speakers. We have about 5 minutes left for questions from you. So anybody have any questions, like to start things off? Yes, please. Yeah, you have to say.
Hi everyone, my name's Daniel Frankson. I'm a professor at the University of Queensland in Australia. My question is for Rajiv. You talked about the multi-country technical assistance of cement decarbonisation roadmaps. My question is really, why not also include the aggregate component? So binder and cement, the sustainability of that is very important, particularly from a CO2 perspective. But more than X%. The majority of concrete is going to be the aggregate component, which has its own sustainability issues. We are looking at both when we're in our Blue Concrete initiative, which is there'll be an event tomorrow at the Moana Pacific Pavilion at 3 p.m. If anyone would be interested in coming to look at what we're doing there. But it's essentially looking at the LC3 change in the Pacific, but also looking at the sustainability of the aggregate component. So I'm wondering if your multi-country technical assistance decarbonisation roadmaps could also include that aggregate component as well as the binder. Thank you.
Yeah, means definitely it depends on what the countries ask us, you know. But our experience have been if we have too many issues combined together, it becomes rather a complex thing and it takes a longer time to implement. But we are totally dependent on what the countries are asking us to do. So if for the same problem we break down in a small basis and we start attacking one after the other in a series of fashion, it leads to a kind of a faster results rather than bringing all the stakeholders together and you know, trying to solve a complex problem. But again, as I said, the kind of approach which I described is just what we are suggesting to the countries. It's not a binding on them. So if they want to have a more aggregated approach, we would be happy to support them. The CTCN would be happy to support them. But in quite a number of other technical assistance not related to the cement sector, what we have observed is, for example, in industries, means most of the countries or number of countries, they do not have Industrial Energy Efficiency Act or laws, and that does not provides a mean of an incentive or a regulatory mechanism for the industries to reduce their carbon emissions. They keep on emitting more and more. They don't have any standards. They don't have any specific energy consumption standards. So the best way to do is that you develop these kind of standards, you develop these kind of targets for each of the sector, which forces the industry to adopt through regulatory means. And see, we are working with the government, so we want the private sector participation, and we want to help and support them and enable them to adopt new technologies. But at the same time, we also work with the government, more with the government, and the government has more power on coming up with kind of regulatory standards and these kind of an approaches or definite policies which would help and support or which would help accelerate the adoption of new technologies. So we are country driven. We would like to support countries in whatever they ask us, and if there is a country X which asks for a kind of an aggregated kind of an approach, we are more than happy to deal with it.
Okay, thank you. So any other questions or